Hey guys, so we are going to be talking about parent functions today, and basically in order to do transformation, which is the goal of this entire unit, you need to understand which function the transformation comes from and which function are we going to apply the transformation to. So we are going to introduce 6 functions for you. Over here we have quadratic, cubic, absolute, root function, reciprocal, exponential functions. You guys are required to know what these functions will look like before we actually apply transformations to them. So it's important that you know the domain range, you know the shape of the graph, and you know what kind of table of values they should have. So I'm going to start off by showing you how to draw a quadratic function. So over here we have a quadratic function. This is the base function. You can see that, not the perfect drawing. So when we're creating a quadratic function, what we want to do is we want to use good x values. And for me, whenever I create a quadratic function like this, I like to use -1, 0, and 1. Because I can immediately do in my head mentally that this part is going to be a +1, this is going to be 0, and this is going to be 1, right? Because over here, if we have -1 to the power of 2, that's going to be a +1. If we have 0 to the power of 2, that's going to be 0, and this is going to be 1 to the power of 2 is going to be 1. So there you have it. Now, when we're looking at domain range over here, we can see that there is no limitation in terms of how far we can go to the left and no limitation on how far we can go to the right. So as a result, we know XER, right? And in interval notation, that is going to be -infinity and +infinity. For range, however, for y equals x squared, we do have some limitation. We can go all the way up, but we cannot go all the way down because we have to stop at 0. So y must be greater than or equal to 0 over here. So as a result, for interval notation, it is going to be square bracket 0, comma, infinity, round brackets. All right, hopefully that makes sense to you. So now we're going to move on to cubic function. Cubic function should look something like this. Very curvy, like that. Whenever I am drawing a cubic function, the related table of values for me, I always use -2, -1, 0, 1, and 2. Okay, so y equals 0 to the power of 3 is 0, 1 to the power of 3 is 1, 2 to the power of 3 is 8. And when you have y equals bracket -1 to the power of 3, make sure it's in brackets, this is going to give you -1. Y equals -2 to the power of 3, in brackets, of course, this is going to give you -8. So you can see that at 0, 0, right over here. 1, 1 is roughly around here, right? -1, -1 is roughly around here, and 2 to the power of 8 is roughly here, and -2, -8 is over here. Domain. Obviously, no limitation to the left, no limitation to the right. We know it's going to be -infinity to +infinity. For range, you can keep going down, you can keep going up. Again, no limitation. So it's going to be -infinity and +infinity. All right, the next thing that we need to introduce is absolute function. All right, so absolute function looks like a V, like that. All right, let's create the x and y values. So when we plug a 0 into the absolute function, we get 0. When we plug a positive number like 1 into the absolute function, we get a positive number back. And when we plug in any negative numbers into the absolute function, we also get a positive value back. Okay, which explains for the V shape over here. So in case you're still confused, 0, 0 is right over here. 1 and 1 is over here. Negative 1, 1 is roughly around over here. Okay, so again, for any numbers that go into the absolute value function, it's going to come out positive regardless. You put in 100 in here, it'll give you 100. You put in negative 5,000 in here, the function, the value will come out to be positive 5,000. Okay, so let's create the domain. You can see that we have no limitation going to the left and no limitation going to the right. So you have negative infinity, positive infinity. And in terms of the range, again, we can keep going up, but we have to stop at 0. We cannot keep going down. So it is going to exactly like the range over here. So we're going to have negative, oh, nope, not negative, square bracket 0 and positive infinity. So again, for the range, you can keep going up, which explains for the infinity sign. And when you go down, you can only reach 0. Okay, so that's why a square bracket, because 0 is possible, but you cannot go further than that. All right, so let's move on to these three: the root function, reciprocal function, and exponential function. Now, before I can do these, fill in the blanks over here, let's move on to the next page. So over here we have exponential functions, and you can kind of see that I want you guys to sketch the two graphs over here. Now, I will obviously do them in front of you. I'll create a table of values, and you guys can see what kind of values I use to create these table values. Now, I want to use x values that are easy for me to calculate the y mentally. So for me, obviously, I'll definitely use, things like -1, 0, and 1. If you need more values to draw your graph, then obviously you would go -2 and 2. Okay, so let's begin over here. 2 to the power of 0 is 1. You can go home and think about that a little bit. All right, you plug the 1 into the x over here, 2 to the power of 1. Obviously, it's going to be 2. To the power of 2 is going to be 4. That's easy to do. Okay, what is a little bit harder is when you put in a -1 as an x value. Now you have 2 to the power of -1. It is not -2 over here. 2 to the power of -1 is 1 over 2. Right? Because you have to remember that whenever we have a negative exponent, it means 1 over. So if we have 2 to the power of -2, it'll be 1 over 2 to the power of 2, which is 4. Right? It'll be 1 over 2 to the power of 2, aka 1 over 4. All right, let's create the table values for this exponential function over here. So if we have an x value of 0, we have half to the power of 0. Anything to the power of 0 is 1. Okay, half to the power of 1, that's going to be 1 over 2. Half to the power of 2, this is going to become 1 over 2 to the power of 2, aka 1 over 4. Half to the power of -1, this is going to become, right, 2 over 1. That's going to be 2. Half to the power of -2, right, this is going to become 2 over 1 to the power of 2. So that's going to be 4. So just like that. Okay, let's graph this. Okay, so 0, 1, right over here, 1 to the power of 2, like that. 2 to the power of 2 is 4, and this one is right over here, negative 1.5, negative 2, like that. So what you need to know about the exponential function is that we actually have an asymptote, a horizontal asymptote over here, and we slowly go up. Now excuse my drawing, it's really hard to draw on a tablet from my desktop. Like that, goes up. All right, now when this red curve comes down, it doesn't go through the x-axis because there is a horizontal asymptote there. All right, let's draw the f of x equals half x over here. Negative 2 to the power of 4. It's right over here. Negative 1, comma 2, 0, half, and 1/4. All right, this is even harder to draw for me. And we have a horizontal asymptote like that. Okay. So let's look at the domain and range of each of these. So I'm going to make some correction over here. Range of that, and let's do domain and range for this function as well. Okay, let's begin. Oops, sorry about that. Okay. So domain of y equals to the power of x, you can see that there is no limitation going to the left, there is no limitation going to the right. So as a result, we can go negative infinity, positive infinity. For the range, we can keep going up, but we cannot go past this x-axis. Now, in fact, we cannot even be on the x-axis because there's a horizontal asymptote there. So as a result, it has to be 0, round bracket, because we cannot be a y value of 0, and we can keep going up like that. Now, if you have a problem understanding that, I am going to put the set notation here, just in case you're wondering how to decipher this. So y gotta be greater than 0. All right, let's talk about domain and range for this one over here. So as you can see, again, there's no limitation going to the left, there's no limitation going to the right, so it is going to be negative infinity, positive infinity, XER. We can keep going up, but we cannot pass, again, the x-axis, and we cannot be a y value of 0 either. So hopefully you can see that it doesn't matter if the exponential function is rising to the right or if the exponential function is falling to the right. They actually both have the same domain and range. So now let's go back to the previous page and fill this part in over here. when you're asked to draw an exponential function, this is the default exponential graph to draw. This one. Okay. And the domain, as you figure out from the previous page over here, this is going to be negative infinity and positive infinity. Right? No limitation, no limitation. For the range, this is going to be round bracket because of the horizontal asymptote that you cannot pass, and positive infinity because it can keep going up. For table values, as example, my favorite to use is y equals 2 to the power of x, right? So this is going to be 1, 0, 1, and over here, this is going to be half, and this is going to be 2. Now, you don't have to use y equals 2 to the power of x as an example. You can use, 3 to the power of x, 4 to the power of x. Obviously, this value over here will be different, but whatever makes it easier for you to draw the graph of exponential function. For me, I just use this all the time to represent an exponential function. All right, so the next thing that we need to do is explore the root function over here. So whenever we ask for a root function, this is what I expect people to draw. Like that. Okay. So why is the graph looking like that? It's actually very, very simple to demonstrate. Okay. If we square root the 0, we get 0. If we square root 1, we get 1. If we square root 4, here, we get 2. And we square root 9, we get 3. So you can see we have 0, 0, 1, 1, 4, 2, and 9, 3, roughly around there. Okay, so that's how the graph looks. So based on this graph over here, we can see that in terms of x values, we start at 0. Okay, we can be 0, and we keep going to the right. There is no stopping us once we start moving to the right, but we have to start at 0. Okay. In terms of the y values, the range, again, we can be anything up high, but we gotta stop at 0. So it is gonna be like that. Okay. So x can be greater than or equal to 0. And that's the same thing as the y, the range. Y is greater than equal to 0. All right. All right, so let's examine this more. Okay, let's talk more about this over here. All right, the first question is, in a root, why are we only using positive x values in table? So in case you forgot what I was doing on a previous page, over here, I'll do it again for you. Over here. The question is asking, how come these numbers are all positive? Now, the simple answer to that is because you cannot square root negative values, right? We can square root 0. We can square root 1, right? We can square root 4 because we cannot have negative numbers inside. So because we cannot square root negative values. All right, what is so special about the x values chosen and why were they chosen? So in case you haven't noticed over here, I went from 0, 1, and then jumped to 4, and then jumped to 9. There is a reason for that, because when I choose my x values, I want to pump out the y values easier. If I chose square root of 2, that would give me a decimal over here, and that's difficult to do and time consuming for me to pick up a calculator and punch it in and get the answer when I simply just want a sketch of a graph. So that's the reason why I chose these numbers, because these are perfect squares. So what's so special about the x values chosen? They are perfect squares. Okay, they're chosen because they give y values that are easy to calculate mentally. Okay, so hopefully that makes sense to you. All right, so the next thing that we need to talk about is reciprocal function. So reciprocal function usually, well, not usually, it has the form of f of x equals 1 over x. So let's start off by creating a table of values over here. Okay, 1 over 0, undefined. Right, because you cannot divide something by 0. Let's sub in 1 over here, 1 over 1. Right? If you put a 2 over here, 1 over 2. Okay? If you put 1 over half, that's going to become 2. Right? You don't have to take my word for it. You can try doing it. 1 divided by 0.5, that's going to give you 2. Over here, this is going to be negative 2. Okay? 1 over negative 1, that's going to be negative 1. 1 over negative 2, right? That's going to be negative half. So let's graph this over here. Negative 1, negative 1, negative 2, negative half, right over here, negative half, negative 2, so this is negative half, negative 2 is roughly around here, half and then 2, half, 2 over here, 1 comma 1, and 2 comma half, just like that. That. And like this. So that's what the graph looks like. So in case you haven't noticed, we do have 2 asymptotes. Okay, so let me just label where the asymptotes are for you. So that's going to be one right over here and 1 that's right over here. All right, so this vertical one is called a vertical asymptote, and this horizontal one obviously is called the horizontal asymptotes. So let's talk about asymptotes. Okay, we have touched on this before. Essentially, asymptotes are imaginary lines. That the graph or the function does not pass through. Now, you will learn later on in grade 12 that there are certain asymptotes that can pass through, but we're not going to touch that for now, okay? So for now, you're going to learn that asymptotes are imaginary lines that the graph or the function do not pass through, okay? And that's what we're going to be talking about next over here. Where are the asymptotes on the reciprocal graph? So This over here is a vertical asymptote. It is a line. It is a vertical line. In grade 9, you've learned that whenever you describe a vertical line, it starts off with x equals. So in this case, this is x equal 0, okay? That's the line equation for the vertical asymptote. And over here, this is a horizontal line. And to describe horizontal line in grade 9, you always use y equals. In this case, because it is on the x-axis, it's going to be y equals 0. So this is the equation of the horizontal asymptote. All right, so let's take a look at the domain and range over here. So let's start by talking about domain. So we can start, going all the way to the left. There is no stopping us. We can go all the way to right. There's no stopping us. However, you can see that when we start coming from the left to the right, keep moving, 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 but we cannot ever be an x value of 0, right? And once we get past that, then we can continue on again. So basically for domain, you can be any numbers except for 0. So x are all real numbers such that x cannot be 0. So again, any numbers you want except for 0. Okay. Now it's the same thing for y. You can be as negative as you want. You can be as positive as you want. You just cannot be a y value of 0. So here's the range. Now, I don't have enough space over here, so I'm just going to write interval notation on this side. So for domain over here, as negative as we want, okay, but we just cannot be 0. Notice how it's round bracket because we cannot include the 0 as part of our domain. And then we start again, heading towards the positive side. So 0, comma, positive infinity. And we're going to do exactly the same thing. We can be as negative as we want. We just cannot be 0 over here. And then we start again. We start moving up to the top. So 0, infinity, just like that. Okay, so these are my domain range in set notation. These are my domain range in interval notation. All right, so let's bring this whole thing back over here. So whenever someone asks you to draw a reciprocal function, you should automatically draw something like this. All right, and just give me a second. Like that. Okay. So again, you cannot be at 0. So this is going to be negative infinity, 0, 0, positive infinity, and negative infinity, 0, 0, positive infinity. And these are the x values I always use. Okay, so D and E. -1 is going to be -1, and 1 is just going to be 1. And if you need more, obviously go -2 and 2 over here. But yeah, usually I just do -1, 0, and 1. Okay. All right, so that concludes the very first lesson of this series for 1.3. All right, but before I end off this, let's summarize everything that we have learned today. Okay, sorry, it is not over yet. Let's summarize everything that we've learned. So the purpose of today's lesson again is because you guys will have to transform graphs. However, you can only transform graphs if you know what they look like originally. So that involves knowing what table of values you should be using to apply the mapping rule later on. So it's actually very essential for you to be able to recognize these functions as quadratic, cubic, absolute function, root, reciprocal, and exponential function. Then write the table values and apply mapping rule to it. Okay, so that's why, again, you need to know the properties of these.